Hey everyone, welcome back. Hope you are enjoying things, whether you're watching it from start to finish, whether you've been here from video 1 to now. Either way, I think that there's some good nuggets of information in these videos, and I'm really trying to apply the concepts of the CCNA and CCNP tracks to kind of real life situations. So I hope I'm doing a good job of that. Please provide feedback whether I'm doing good or bad. I know I'm having fun recording these things. It's been a little bit of a challenge at some points because some of this stuff has been a while since I've configured it. So, at any rate, let's jump right in. The last video we left off with doing our basic BGP peerings from data center 1 up to the MPLS, and we established BGP. We got some routes from the branch sites, but our routing is incomplete. So we haven't even touched routing in the core of the data center. So I'd like to introduce the EIGRP peerings that we had discussed last time. So we're going to go ahead and we're going to configure these peerings, these 4/30s between the WAN routers and the cores. We will also get the HSRP, or excuse me, the SVIs on the cores. We're going to get those subnets into EIGRP as well. And we're going to have to do some route redistribution here between EIGRP and BGP because our WAN is running BGP. So in order to get some of these routes to the branches, we're going to have to do that, and vice versa. And then we probably have some pretty irate employees at branch sites because as of right now, they don't have any internet connectivity. All they can do is talk to each other and part of the data center right now. So let's see how far we can get. You know, it might turn out to be a little bit longer video because we got a lot of routing to get through. So let's see how far we get. If we can knock it off in one video, that'd be great. So let's jump right in. So on the cores, we'll start with those 4/30 peerings that I was talking about. So the first thing we're going to have to do is we're going to have to turn on feature EIGRP, okay? Because remember, out of the box, none of the features are enabled. So let's go ahead and do that on both cores. So now we should be able to activate the EIGRP process. So we're going to give it a name. We're going to say EIGRP AS. What are we running here? We said 65,001, right? For BGP, we might as well just keep it the same for EIGRP. I see no reason to change it. Should be okay. All right, so let's go ahead and do that on core 2. And let's go ahead and get these peerings done. So where am I at here? So gig 3 goes to 1.3 on core 1. Okay, so 1.3 is probably default, right? So we're going to make this a no switch port this time. So interface E13, we're going to say no switch port. We'll give it IP address. Let me bring up my cheat sheet, put it over here. So we're on WAN router 1 and core 1. So we're looking to configure this link here. So the core is going to get 10.101.253.1/30. Okay, and then we're going to say IP router EIGRP, and then we'll tell it the instance. And then what I'm going to do, oh, never mind, that's fine. Yeah, so that's fine. And then we're going to do same thing on 1.4, that's facing the other WAN router. So WAN 02 and core 1, that's this link here. So 10.101.253.9/30. And then we'll hit the up arrow a couple times, grab the EIGRP. Okay, good. Show interface status. So we configured 3 and 4. All right. Now let's go to, it doesn't really matter what order we go. We'll go to core 2. So core 2 to router 1, that would be this link here, and that is 1.3. So he's 10.101.253.5. And then he's going to get IP router EIGRP. Okay. ETH14 goes to WAN router 2. That's this guy here. 10.101.253.13. Okay. All right, so that should be enough to get our peerings up from the core's perspective. Let's hop over to each WAN router. So DC1 01, show run section EIGRP. There's nothing there. It just occurred to me, I think I forgot a command. We have to tell the cores the autonomous system number. So, autonomous system number 65001. Okay. So we're going to just pump that into core 2 as well. Okay, good. All right, back to WAN 01. We're going to say address family IPv4 autonomous system number 65001. All right, and then we're going to put the network statements in really quick. So DC1 01 to core 1. So that's these links. So that's going to be 10.101.253.0. Okay. With the wildcard mask that's indicative of a /30. And then we'll hit the up arrow and basically put in the .4 as well. Okay. So that's our network statements. Let's do the interfaces real quick. So we're looking at 3 and 4. So we'll say interface gig 3, no shut. And this is core 1, WAN on core 1. So that's this IP address here. IP address. That's a /30. Okay, we can see that we've already got a neighbor up, so that's good. Let's go to interface gig 4. Let's no shut him. And he's going to get .6. Come on, work with me here. Okay. All right, awesome. So it looks like we got 2 neighbors. Let's just finish off WAN 2 real quick, and then we'll do some quick verification. Show run section EIGRP. RP, nothing there. All right, so I'm on WAN 2, gig 3. He's going to get .10. All right, and then gig 4, he's going to get 14. And then we'll go under the, we'll define our EIGRP process. and we'll do the two network statements for WAN 02. So it looks like .8 is going to be our network address. So .8.0.0.0.3. We'll hit the up arrow, and it looks like 12 is our other one. Okay. All right, so it would appear we've got two more neighbors. That's awesome. So on all the boxes, we should be able to do show IP EIGRP neighbors. All right, and we can see that we now have our two neighbors from WAN 1's perspective. Let's just double check. WAN 2 has the two neighbors as well, and then obviously that means the core should be seeing two neighbors as well. So that establishes the EIGRP adjacencies between each core and each WAN router. Now, let's go back to, well, before we do this, right? So if I do show IP route on the WAN routers, okay, so we're looking for D routes, okay? So D routes are EIGRP. So we can see that we're going to have nothing more than the /30s, okay? So just essentially the links between the devices. We didn't learn anything as far as VLANs go, you know, that live on the cores. So on the cores, if you recall, we have all these VLANs, right? So we're going to want to get those VLANs into EIGRP, okay? So we want the rest of the network to know about these VLANs, because if somebody on site A or site B needs to contact one of these servers, maybe these are web servers, whatever they may be, who knows? Maybe the developers need to get to them, like there could be any circumstance. But the point is they need connectivity to these servers, right? Without putting these VLANs into EIGRP, you're never going to get that connectivity. So let's go ahead and get that done. So show run interface VLAN 101. All right, so we're going to basically go into each one of these. So let me see if I can script this. Maybe it will be a little bit easier on us. Interface VLAN 101. So we'll do it on the first one, and then we'll see if we can copy paste the majority of it. So we're going to say IP router EIGRP, and then we need to get our process, which we know is EIGRP AS65001. Okay. Now I am going to introduce another command under this VLAN interface. So I'm going to say IP router EIGRP. If I can remember where it is, IP passive interface EIGRP, and then the process. Okay. So why am I doing this? I'm doing this because I don't want my core switches to try to peer up with one another across every one of these VLANs. There's no reason to do that. EIGRP does equal cost multipathing, or ECMP, and what will happen is if I don't put the passive interface in, it will establish adjacencies multiple times and just start throwing the routing table off. Like it'll work, but you don't want all those peerings because it's not necessary. So we're going to make sure we turn passive interface on these VLAN interfaces. All right. So at this point, we should be able to do the same thing for the other two VLANs. So interface VLAN 102, basically same exact commands. And then for interface VLAN 254, okay, same two things. So let's go ahead and just dump that into each core. All right, so now if we come back to our WAN router and we hit the up arrow, okay, what do we have going on now? So a lot more D routes now, okay? So we can see we've gotten specifically 3 more D routes, right? Because we've added EIGRP on 3 VLANs, so that makes sense, right? But the point is now we've got the IP routes for all the VLANs in the cores. It should make its way up to the WAN routers. So now the WAN routers, yeah, that's what I was just checking, I'm sorry. The WAN routers have already learned those D routes. So you can do more specifically, show IP route EIGRP. So we can see that the EIGRP portion of the routing table is now growing, right? And that's what we want. We want to make sure that we want full connectivity across the board here. So the problem now becomes this. So let me minimize that. So the WAN routers have show IP route BGP. So they have all these BGP routes that they learn from site A and site B. They have all the EIGRP routes that they learn from the devices below them inside the data center. But the problem is they're not exchanging those routes, okay, between the two instances of routing protocols. What do I mean by that? If I go over to branch A R1 and let's do a show IP route. So this is kind of what I mean. So we have, remember, we didn't do EIGRP on the sites here. We did static routing because it was just a demonstration on how to get connectivity. We could certainly introduce EIGRP, but for the purposes of this, we're not going to bother. I have something else lined up for future videos. But right now, we'll leave that static route there. The only routes we're learning dynamically are BGP routes through the service provider from both site B and the data center. We're not learning those EIGRP routes because, again, we're not doing that redistribution between the protocols on the WAN routers. So let's go ahead and do that, all right? And we'll see what changes. So just for sanity's sake, we'll check the routing table on branch B as well. So we have a copy of it on both branches. So we can kind of do a comparison after we do this redistribution. So let's come over to WAN 01. And we want to essentially take EIGRP routes and put them into BGP, and we want to take BGP routes and put them into EIGRP, okay? So we basically want to do mutual redistribution. So we have no statics, no nothing, okay? Let me look at the cores. Did I misspeak when I just said that? No, we have a, okay. All right, let's do it. So on WAN 1, show run section EIGRP. So let's come under EIGRP. And redistribution command does not work here. You actually have to go under the topology base section, and then redistribute shows up. So we're going to redistribute BGP 65001, and we'll do the metrics. So we'll say 1000, we'll say 10, 255, and 1500. So I should be able to just paste this exact same thing on WAN 02. All right. So quick spot check on the cores. Let's check the core now. So look how big the routing table is starting to get here, right? So now we're almost at 2 pages of routes, okay? Let's do... So you can see all these routes are new, right? They just came in 8 seconds, 27 seconds. So the time it took me to do router 1 versus router 2 was about 20 seconds, right? So we can see that we're learning them from both routers, which is good. And they're tagging them as external. I know it's cut off here. Let me see if I can do a term width 511 show IP route. There you go. That's a little bit more readable. So yeah, so we're learning external routes, and you can see it's tagging them as 7029. What's that? That came from the MPLS cloud. So you can kind of get a sense of where they came from, which is kind of nice, right? So we've got the routes in EIGRP at this point, but that should not help the routing table on the branch sites yet, right? So they still haven't learned the EIGRP routes, right? So nothing's changed branch side, but however, the WAN routers tables look much better now, or the cores I should say, right? So let's do the same thing. So show run section BGP. So let's go under BGP now. Let's redistribute EIGRP 65001. And for metric, we'll just put 20, okay? All right, so you got to be careful about pasting this in. You don't want to overwrite something. You don't want to break something. All right, so that should be good. Okay, so now let's see if anything changed on branch side. At first glance, it looks like the table got bigger. Okay, so there is a whole bunch more BGP routes. We can see from a timing perspective, it looks like all of these routes are fairly new, right? 22 seconds. So now we have BGP routes for all the data center subnets. So that's good. It's looking promising. How about site B? Let's check site B. Yep. So we have all these routes that have been in there for 53 seconds. So that looks really good. Let's do a connectivity test and see. Let's just see what we got going on here. So did we get connectivity is the question. So let's hop over to PC3 and site A. So this is an old ping. We're going to try to ping server 1. So what's server 1 should be 10.101.101.11. Can we ping him from branch A? We can't ping him yet, okay? So there's must be more to this puzzle, all right? So my suspicion is that there's some gaps in routes. So let's just spot check WAN router 1. Show run section BGP. Okay, so only thing we're doing is redistributing EIGRP. We don't have any network statements. So is service provider router 1, let's hop over here. Show run section BGP. So for Cisco, there's 2 network statements, one for 0 and 1, which I believe are the 2 links, yep, going to site A in the data center. So they're advertising the /30, so that's good. All right, so that's promising. Service provider router 3, show run section BGP. So same story there. It looks like they're doing the advertisements for the 2 /30 links. WAN router 2. Yeah, no network statements, right? That's fine. I mean, we don't necessarily need a network statement if we're doing the redistribution bit. The question though is 3 and 4. So let's get specific with what routes we're gonna and then we can start to do pings one hop at it, or hop by hop, to see how far we get. So let's go back to router 1 and site A. And let me bring up my cheat sheet here. So we have the 4 /30s. So the question is, can we ping? Let's go to PC3 and ping 10.1.2.1. So he can ping his gateway. All right, well that's good. He should be able to ping core 1. Can he ping this address? No. So there's something going on between the branch and the data center, okay? So we're essentially not able to communicate. It looks like the routes are there, but we're not able to communicate. So let me check router 1. So we are advertising the entire /22 that supposedly belongs to our site. Okay, we have a static route for it. Ping 10.1. What was PC3? 13. So let me go to WAN router 1. He has the /22. I knew I was going to do that. Okay, so WAN router 1 can ping that PC, right? But it looks like the PC can't ping the WAN router. Right? Is that what we're seeing? So the WAN router was able to ping that PC in site A and sourcing it from all 3 of its interfaces, and it worked fine. I would suspect okay, so from my perspective, the WAN router has connectivity to the branch. PC3. Okay, so the PC can ping .2. I'm going to assume it can ping 6. Maybe it can't ping this one, which might be the problem. Nope, it can ping that. Okay, fine. So there's complete connectivity from the PC to the WAN routers. However, if I try to go one hop further, okay, he's got connectivity there. How about VLAN 101? Okay. It could have been a convergence time. Well, hold the phone, because I don't know. So that's, we still didn't ping all the way down to the server yet. So we got all the way to the cores. The server 1. I mean, let's just do a quick sanity check. So 1.1 is VLAN 101. Okay, it's connected. Show MAC address. We can see that we are learning AC65. Oh, well, that's interesting, isn't it? So That's really interesting. AC65 is hanging off port 11. Wait, I'm sorry, I'm looking at the wrong port. I don't even see a MAC hanging off 11. So that might be part of our problem here. Let's restart this server real quick. All right, let's reconnect. Top of rack switch for E11 should be VLAN 101. So 10.101.101.11 for server 1/24. Gateways 10.101.101.254, right? Show run interface VLAN 101. Yep, 254. Can that server ping his gateway? Yes, he can. Okay. Let's check that MAC address table one more time. E11. See, this looks better. E11 681A. 681A. That looks a lot better. APC3. We want to essentially try to ping the server. There we go. Those virtual PCs, man, they're killing me. Absolutely killing me. But we did some troubleshooting. We took it one step at a time, one hop at a time. But the good news is it looks like we now have connectivity all the way from branch site A into our data center and vice versa. Let me just do the opposite ping, right? So let's ping 13 from server 1. Good. That looks great. All right, where are we at? We are at 32 minutes. Let's see if we can just nail down the default route real quick. I think 32 minutes is reasonable. So if I look at branch site router 1, right, and I check the routing table, we don't have a quad 0 route, okay? It's not there. So that means that this site has no internet connectivity whatsoever, right? It's only allowed to communicate with everything in the WAN, which is fine, but no internet access. If we go back to WAN router 1. Let's see, show IP route. Okay, so we can see that there's no default route being learned on WAN router 1 either, okay? If you recall, the firewall, right? So let's go to the firewall. Show IP route. So the firewall has a static route that is for the internet. So if we ping Google, right, we can get to the internet from the firewall. But the problem is the firewall is not advertising that route to the cores. Show IP route. Okay, it's not being learned. It's a static route on our core switches. Okay, so we can see I should be able to ping the internet from the core, right, which I can. The problem is we did not, in EIGRP, right, we didn't do any redistribution for static routes. And if you remember, the only thing we turned on was the routing process for the /30s between us and the WAN routers. So all we should really have to do here is advertise the default from each core into EIGRP, okay, with the redistribute static command. So let's go ahead and try to do that. So show run section EIGRP. So let's come down here. Let's redistribute static, all right? Okay, so The cores want a route map. So they're forcing us to use a route map. So, which is fine. So we'll say route map static to EIGRP route map. Okay. So let's define what that route map is. So we'll say route map static to EIGRP route map. We'll say permit 5. Okay, and we'll say match IP address in prefix list. So now we're going to have to define a prefix list. All right, IP prefix list. That we're going to say sequence 5 permit 000/0. So we should have a section prefix list. So before we define this on core 2, let me go to WAN router 1. And now if we check our routing table now, we can see that we have an external EIGRP route for the quad 0. So does that mean we can ping the internet? Yes, it does. That's a good sign. So let's come over to A router 1, show IP route. Okay, so we still didn't learn a default route at the branch side yet, okay? However, we got it to the WAN router, which is good, okay? So let's go ahead and configure core 2 with the same prefix list and route map. So that's the prefix list, show run section, route map. So let's get that on core 2. And then last but not least, show run section EIGRP. Alright, so now we have the redistribute static on both cores. WAN router 1 is learning the default as well as, let's just check WAN router 2. Yep, so they both have it. But the problem now, I believe, is going to be with the BGP config. So we don't have any network statements in there. Okay, we have a redistribute EIGRP. But that's clearly not doing us any good. So let's try to, on the WAN router, let's come under BGP. Under the address family, and let's do network 0000. All right. So let's put the network for quad 0 under BGP. And let's go over to branch A. Let's hit the up arrow and check it out. Now we have a BGP star default route. Okay, so do we go for the glory now? And look at that. So now we can ping 8888 from our branch site. That is beautiful. So let's do a trace route. We can see our hard work, or the fruits of our labor. check it out. So now, so again, we're sitting on we're sitting on PC3. He is on VLAN 300, so 10.1.2, right? As we know, 10.1.2.13. His default gateway is 10.1.0, or excuse me, 10.1.2.1. So we throw that packet over to our default gateway. We then, on branch site A, we switch over to VLAN 100 to get up to the router and out. So we go to 10.1.0.1, so that's proper. Now, in a real world situation, you know, the service provider, again, he's going to disguise the hops inside of their cloud. You know, at some point, you won't see hops in between. This is actually the MPLS IP address leaving site 1. Then we go to 0.2, which let's, well, before we hop over there, we'll do that in a second. So we land on 192.168.0.2. That's either going to be WAN router 1 or 2, which we're going to check that in a minute. And then we can use the same logic that we did on the internet side of the house, which is, do we want to favor one circuit or one router over the other, right? So right now, BGP just kind of figured it out, and it allowed that traffic to one of the two routers. We didn't influence it, right? So then we go to 10.101.253.5. So actually, we can check our cheat sheet here and probably get a sense. 10.101.253.5. So that is, okay, so that's core 2, okay? So what happened was it came in and it went to core 2, right? So it either came through router 2 or 1, which we'll check in a minute, and then it threw it to core 2. Core 2 then bounces it up to the firewall, which is the 254.5. The firewall nats it to our 101.1.0 IP space that we advertise out to the world, or the internet. And from there, we go out to the internet and we're able to ping. So that is a that is a fully functional, complete WAN environment with data center on top of it, or in the mix. And I think what we'll, so before we hop back, I wanted to introduce something to a branch site, but I'm curious to see the which router it traverses, and then if we want, we can look at influencing that, but I think it's kind of a duplicate effort. We've already done it on the internet side. There's no real reason to do it again. It's the same exact thing. So 192.168.0.2, right? Yeah. So we came through router 1, all right? So what you could do if you wanted to is, you know, let's say we had to do a maintenance, or, you know, let's say for whatever reason one circuit was having issues, or maybe it had intermittent latency or something. It was up, but it was degraded or something like that, you know? We could favor traffic in and out the same way we did the internet, right? ISP-A versus ISP-B. So the same rules apply with, you know, BGP in this regard. So that's something you can consider and do. I do want to kind of take this environment to the next level. So we're going to start to introduce some new concepts with overlays and DMVPN and simulate kind of like an SD-WAN environment. So that's kind of the direction we're headed. But right now, I wanted to kind of just lay the groundwork of a fully functional data center WAN environment. You know, we explored the 2 customers, which was kind of cool. But we're really just focusing on one customer right now, which is our, you know, our fake Cisco site. So since this was a quick video, let's stop here. Let's go ahead and stop here. I know we're at, you know, we're over 40 minutes here. So let's take a break. And then what we'll do is next video, we will introduce internet back to site A and site B. And what I mean by internet is direct internet access. So right now we have a backhauled internet that goes all the way across the WAN to the data center. what we want to do is we want to introduce direct internet access. Okay, so if you recall, our colleagues or fellow workers were upset because they didn't have internet access. We've since given them internet access, but now they're complaining because it's slow. All right, because it's backhauling through this WAN, out the data center, yada yada yada. So now we have yet even more work ahead of us because we need to keep our employees happy. So what we'll do is we'll introduce direct internet access in Site A. We'll apply our NAT like we already know how to do. We'll make sure that our default route favors that direct internet access connection over the data center. And we'll deploy some mechanisms to keep it automatic. So if that DIA goes down, it should fall back to going out the data center. So we'll walk through that. It's nothing new. It's stuff that we've already done. So we'll reinforce some of those concepts and we'll apply them in a more functional manner, if you will. So I will see you guys on the next one.